Okay, so here's a solution for this is problem number 1 from the quiz that was given on Monday, March 30th. It's double integrals over rectangular Cartesian and polar coordinates. So let's just start working through this first problem. So I want to evaluate this double integral over this region only in the first quadrant. That's going to help us in a second. So what I noticed here is I'm looking at a disk in the xy plane that has a radius of square root of 2. That's telling me that I want to convert this into a polar representation, because I can write this as r squared is less than or equal to 2, so that I can get a bounds for r. So I know that my r value needs to go from 0 to the square root of 2. If I look at this, so the reason why I'm taking r from 0 to square root of 2 is my radius is measured from the origin. So as I go out a little bit, that's going to give me this circle of little radius, bigger radius, bigger radius, bigger, all the way out until I get to square root of 2. So the next thing I need to do that takes care of my r values, I need to think about where theta is going to go between. If I go from 0 to 2 pi, that will trace out the whole circle. But I don't want to use the whole circle. I only want to use what's in the first quadrant. So that means I'm looking at these angles up until here. I just want that wedge. So I'm going to take 0 to pi over 2. So when I rewrite my integral in terms of polar now, those are going to be the bounds that I take for r and theta. So the second part is here, my function. I need to remember that my x value is going to be r cosine of theta, and my y value is r sine of theta. So let's put that all together, and let's rewrite this integral as an iterated integral. So I'm going to go the double integral. My theta goes from 0 to pi over 2, and my radius is going from 0 to square root of 2. I have 8 times my x value is r cosine of theta, y, which is r sine of theta, minus 3. And now dA turns into r dr d theta. So I'm just going to start simplifying a little bit to start working this out. Let's see. One, 2, that's going to be an r squared. When I distribute this, that's going to pick up an r, and that'll pick up another r. So I'm going to have 8r cubed cosine theta sine theta minus 3r dr d theta. So now I can integrate this. Let's do it with respect to r first. So that's going to give me this part. So it's going to turn into r to the 4th. So 8 over 4, so that'll be 2r to the 4th cosine of theta sine theta minus 3 over 2 r squared, evaluated from 0 to the square root of 2. So now when I evaluate this, obviously all of these have an r value in them, so when I plug in 0, it's not going to do anything. So I need to evaluate this at the square root of 2 squared. Then I have cosine of theta, sine of theta. This is going to be 2 times the square root of 2 to the 4th. So here, the square root of 2 to the 4th, that's the same as saying 2 squared. So that's 4 times 2 is going to give me 8. So let me insert this simplified right up here. This is going to give me an integral now. I'm going from 0 to pi over 2. I just have theta left. So we said this is 8. I'm also going to simplify this as sine of theta, cosine of theta. That's almost my double angle formula for sine. Sine of 2 theta is equal to 2 sine theta, cosine theta. Since I don't have that 2 in the front, I'm going to multiply it over and make it a 1/2 on the other side. So instead of 8 sine theta cosine theta, I'm going to have 4 sine of 2 theta. And then here, this is going to be minus square root of 2 squared gives me 2. That's going to cancel out with the 1/2 that's down here. So just minus 3. So I get 4 sine of 2 theta minus 3. I want to do this integral from 0 to pi over 2. So here, this is going to be antiderivative now is going to give me a 1/2. So that's 1/2 times 4 gives me a 2. The antiderivative of sine gives me a negative cosine. Minus, and this is going to be 3 times theta. I want to evaluate this from 0 to pi over 2. Let's go ahead and evaluate that on this right here real quick. I have a little bit of space you can see. So I'm going to have negative 2 cosine of 2 times pi over 2 minus 3 times pi over 2 minus negative 2 times cosine of 0 minus 3 times 0. That is 0. This is 1. So it's going to give me negative 2, positive 2. Here, I'm going to have minus 3 pi over 2. And the front here, 2 times pi over 2 is going to give me pi. So cosine of pi is a negative 1. Negative 1 times negative 2 gives me a positive 2. So it's going to be 4 minus 3 pi over 2. That'll be the answer for this function evaluated over the domain, the disk of unit of a radius of square root of 2 in the first quadrant. I do want to point out there's a couple different ways. This isn't the only way that you can do this. Here, when I get to this point, I can separate these so that I have 2 different integrals. So I have the double integral of this first part, and then I have the double integral of the second part. If I separate it like that, this becomes a little easier, I guess. This part, I'm just dealing with the 2 pieces individually. I don't have to do them at the same time. The other thing that I can do is here, you can see me on the side over here, I'm pointing. This little part, I do not have to rewrite this as sine of 2 theta. What I can do is I can leave it as sine of theta cosine theta, and I can do a u substitution. If I do the u substitution, let u equal to sine, and then du is going to be cosine, I can still do this. I'm still going to work through. My antiderivative will look a little different, but I'm going to get the same. I'm going to get the same answer in the end. Okay, so that's question number 1 from your quiz that you took. Solutions. If you have questions, email me. Thank you.